Welcome back to Data Engineering Explained. In this video, we will present three foundational books that provide a comprehensive understanding of data engineering fundamentals. The books that we will discuss focus on the foundational concepts rather than tutorials for specific technologies, making them universally applicable to a wide range of contexts. So, let's dive right in and start with our first book. Our first book is Fundamentals of Data Engineering, which was published in 2022. This book teaches how to assemble various components into a coherent whole data platform, applicable in real-world scenarios. By connecting the dots of the end-to-end data lifecycle, it offers a comprehensive understanding of the data engineering process. Rather than focusing on specific technologies or products, the book emphasizes the data engineering lifecycle itself, because its steps remain constant over time. The authors state two goals they want to achieve with this book. First, to distill data engineering principles that are applicable to any technology. And secondly, to present timeless principles that provide a mental framework to work with data platforms for the future. Next, we will take a look at the contents of this book in more detail. The first part, Foundation and Building Blocks, defines data engineering, maps out the data engineering lifecycle and introduces a framework for choosing the right technology. Part 2, the data engineering lifecycle in depth, explores each lifecycle stage in detail. Part 3 discusses the importance of security and privacy in data engineering, and speculates on the future of the field. Finally, the appendices cover relevant technical topics, such as serialization and compression, as well as cloud networking. Given the comprehensive contents and the stated goal of the authors to look at the fundamentals rather than specific technologies, this is truly a book that is useful for every data engineer. Designing Data-Intensive Applications, published in 2017, is an extremely popular book among data engineers and provides a comprehensive guide to building modern data systems. Similar to our previous book, it does not provide tutorials for specific technologies, but rather explains important concepts that apply to all data systems. The book covers various data models and databases, as well as distributed systems, and delves into the internals of those systems. Examples for this are database data structures and concepts like replication and consensus in distributed systems. Readers will get a solid understanding of which technologies are appropriate for which purposes and how to combine them for a strong application architecture. Overall, it provides an excellent foundation for building data-intensive applications in a scalable, reliable, and maintainable manner. Next, let's take a look at the contents. Part 1 discusses the foundations of data systems and covers the goals of reliability, scalability, and maintainability and how to achieve them. Different data models and query languages are compared, as well as storage engines and data encodings, to help you choose the most appropriate for your use case. Part 2, Distributed Data Systems, discusses concepts of distributed systems like replication, partitioning, as well as transitions and consistency. It also explains how to deal with challenges like network delays, faults, and failures. The last part, Part 3, Derived Data, explores batch processing and stream processing. It also presents how the author imagines the future developments of data systems. The last book on our list is Algorithms and Data Structures for Massive Datasets, published 2022. This book discusses algorithms and data structures that are not running in the classic in-memory single machine context in which these topics are usually discussed. It examines the algorithmic trade-offs and efficiency concerns when working with large-scale distributed systems and applies them in practical problems. Examples for discussed algorithms are approximation and estimation algorithms like Bloom filters and hyperlog-log. Sampling and approximation algorithms on data streams, and external memory sorting algorithms. One of the key takeaways that the authors convey is that with algorithms on data sets that are too big for a single machine's memory, data transfer becomes the bottleneck, instead of CPU or memory. Overall, the book gives a very comprehensive overview of algorithms for large datasets and offers a great balance between theoretical explanation and practical code examples. The importance of the algorithms discussed and working with very large datasets and its practical explanations make this a must-read for every data engineer in our opinion. This was our list of the top foundational books for data engineering. The books presented all help to build a solid understanding of the fundamentals that are applicable to any technology and also will stay relevant in the future. Thank you for watching, and please click the subscribe button.